Let's talk about the graph of the inverse now. When we reverse the direction of the arrows in our arrow diagram, we effectively interchange the x and y coordinates. In other words, reversing the arrows basically means you flip the two coordinates. So what would an example of that look like? If your original point was something like the point 1, 2, then when you interchange the x and y coordinates, those become 2, 1. What is the effect of this on our graph? Well, the graph of y equal to f inverse of x is just the graph of y equal to f of x reflected about the line y is equal to x. So let's take a look at a couple of drawings to illustrate this fact. The dotted green line is this line y is equal to x. Okay. And the red line is our original graph. So our original graph was y is equal to f of x. Now a quick look at this red graph shows us that this graph is 1 to 1. So because this graph is 1 to 1, f of x is 1 to 1. Because it is 1 to 1, this means that f inverse of x exists. And what I've done here is I've graphed the inverse in blue. So if you look at the blue graph over here, this is the graph y is equal to f inverse of x. And as you can see, each point is just reflected across a different point here. So it's reflected across the line y is equal to x. So if we were to write down equations, in this particular case, f of x was equal to the cubing function x cubed, and its inverse function, f inverse of x, is equal to the cube root of x, which we sometimes write in exponential form as x to the 1/3 power. So these two functions are inverses of each other. Now, let's take a look at an example of a different situation. So if we scroll down a little bit, we can see I've set up a scenario where the red graph, our original function, still y is equal to f of x. But in this particular case, the f of x is not 1 to 1. Now let's see what happens when we reflect across the line y is equal to x in green. When we do that, we see that we get the blue graph. This blue graph is not a function. How do I tell it's not a function? It fails the vertical line test. So it failed the vertical line test because the original graph is not 1 to 1. So what we can see is when your original graph fails the horizontal line test, then after you reflect it, the resulting supposed inverse fails the vertical line test. So we can really see that the horizontal line test is checking that the reflected function passes the vertical line test. Okay, so this concludes our discussion about the graph of the inverse function. I just wanted to point out that all the earlier examples that we looked at basically came from x cubed and x squared. So if you looked at those xy tables, those numbers should make it obvious to you. Take care, everybody.